Hello student, let us see in friction how to find out the maximum applied force, maximum value of applied force F, so that this smaller block and this bigger block both will move together. There is roughness between the smaller block and the bigger block, and the coefficient of static friction is given by mu s, and the lower surface on which the bigger block is placed is smooth, so there will be no static friction acting between the lower block and the table. Now a force F is applied on the upper block. Mind it, the force is not applied on the lower block, but the force is applied on the upper block, and we have to find out what should be the maximum value of this force F, so that this block and this block, means upper block and lower block, both will move together. And if you apply more than that maximum force, then what will happen? The smaller block and the lower block will not move, they will start sliding over each other with different accelerations. So let us see the situation. What should be the maximum value of this force F, so that the smaller block and bigger block move together? How to decide this maximum value of force? Now if you see the free body diagram of the smaller block M, we will observe that the forces acting is, F is the applied force acting in rightward direction, and there will be static friction acting between the lower block and the upper block, that will be given by, let us say, Fs max, and we know the maximum value of this static friction is nothing but mu s time normal reaction, and the weight will be acting in downward direction, that is mg. So maximum value of this static friction will be mu s time mg. Is it? This is the situation. And when we draw the free body diagram of the bigger block, we'll observe the bigger block is this static friction which was acting on leftward direction on a smaller block, now will act in the rightward direction on the lower block, and that will be given as Fx max, and that is nothing but mu s mg. And at bottom the static friction is 0 because there is no friction between the lower block and the table. Now you will observe on the lower block, this is the maximum value of force acting in rightward direction, and this will accelerate this block in rightward direction. So I can say the acceleration, maximum acceleration at which both will move together, let us see A0, that will give it as net force divided by mass, and that can be written as net force is nothing but it is the static friction acting in rightward Fs max by m, and I can say the maximum acceleration at which both will move together is nothing but it is mu s time small mg by m. At this acceleration, this is the maximum value of acceleration at which both these two blocks will move together. Right? Now when this acceleration is produced, I can say for the upper block, the net force acting in rightward direction is F minus Fs max, and that will be equal to mass time acceleration of the object. This can be written. So I can say the maximum value of force can be decided from this place, Fs max plus m A0, and this can be written as Fs max is nothing but mu s mg and plus m, and acceleration is mu s mg by m. So I can say this value is mu s mg, I can take common, and this is nothing but 1 plus m. Is it clear? This is the maximum value of force at which both these blocks will move together in rightward direction with what acceleration? With acceleration mu s mg by m. Is it? Now when I take some numerical value here, let us take question 1, and I say, let us take mu s is 0.1, right, and smaller m is, let us take 2 kg, bigger block is 4 kg, right. Let us take g as 10 meter per second square. Now question is what should be F max so that blocks move together. Block moves together. Is it? Now I can directly write this Fs max is nothing but I can take it as mu s mg. I can say the lower surface is having 0, smooth surface. On the smooth surface it is moved. So mu s mg by 1 plus m by m, and this value can be written as mu s is 0.1, m is 2, g is 10, this is 1 plus 2 by 4. I can say this value is 2, 1.5 into 2 is nothing but it is 3 Newton. Now this is the maximum value of force acting on the upper block to keep these two blocks together. And now that common acceleration can be also written as a common, that is common acceleration. From this place you can observe it is mu s mg by m, and this can be written as 0.1 into 2 into 10 divided by 4. So 2 by 4, 0.5 meter per second square. Is it? When you take the numerical value. Now, suppose I say this force is 3 Newton, right? 3 Newton. At this force, these two blocks will move together with common acceleration 0.5 meter per second square. Now, if I say that force applied is not 3 Newton, but it is 2 Newton. Now, when 2 Newton of force is applied, accordingly you will observe at this place the maximum static friction is always 2 Newton. And there 2 Newton will accelerate 4 kg. So we'll observe 2 Newton can be written as 2 plus 4 into A. 2 by 3, 1 by 3, 0.33 meter per second square will be acceleration in that case. And the static friction maximum which has developed is 2 Newton. Now if I take force as 6 Newton. Now in 6 Newton what we'll observe? So this will be lower one will be accelerated with 0.5 meter per second square, because it will be not change. The mu s mg by m will not change. So the lower block will be accelerated with this acceleration mu s mg by m, but the upper block will have different acceleration. So in that case, when 6 Newton is applied, both these two blocks will have two different accelerations. So let us see that situation. What will happen in that situation? How to find out the acceleration? Now, let us take the, suppose in question 2, if I say the force applied is 2 Newton, is it? 2 Newton, and once again mu s is 0.1, m is 2 kg, capital M is 4 kg, G is 10 meter per second square. Now what will be acceleration of the upper block, and what will be acceleration of the lower block, and what will be the acceleration of upper block and all. Now when 2 Newton is applied, you will see the free body diagram. This is 2 kg, right? This is 20 Newton is weight, normal reaction, 2 Newton, external force F applied is 2 Newton, and the frictional force will be acting here is mu s time, and that is nothing but 0.1 into 20, that is also 2 Newton. Is it? In that case, what will happen then? When 2 Newton is applied, that will be not moving at all, that will be remain at rest. Is it? And both these two blocks, M and M will move together. So the common acceleration will be the acceleration of AM and AM, both will be same. That can be written as common acceleration and can be observed by the net force acting is 2 Newton divided by the total mass is 2 plus 4, 6 kg. So 2 by 6, 1 by 3, that is 0.33 meter per second square will be acceleration, and the static friction generated will be 2 Newton. Right. Now let us take another example, another numerical data we'll take, and then we'll find out. Suppose I say in question 3, suppose I say the F applied is now 1 Newton only. 1 Newton. Here applied was 2 Newton, and the same situation. Now when applied force is only 1 Newton, then static friction developed between 2 kg M will be here only will be 1 Newton only. Please mind it. Please check it. This will be Fs now, not Fs max. Now this is normal reaction. This will be 20 Newton, and then force F is applied, that is equal to 1 Newton. Now in this case, the static friction developed between these two blocks will be only 1 Newton. Again they will have common acceleration that can be written as 1 by 2 plus 4, 1 by 6 meter per second square. Now this is value applied force when we are taking smaller than the maximum force. Now let us see some more value of F. Now in fourth example, we'll see fourth example. Let us take fourth example when F applied is 6 Newton now. Now when we apply 6 Newton of force, we'll observe this block, this 4 kg block, the maximum value of Fs max already you know is only mu s is 0.1, 2 into 10, that is 2 Newton, right? So the acceleration of 4 kg will be the net force is 2 divided by mass is 4. So this will be 1 by 2, 0.5 meter per second square. Is it? The maximum acceleration of lower block is fixed, that is only 0.5 meter per second square. But the upper block will be accelerating more. So I can say this is 2 kg now, and the static friction acting in opposite direction to the relative motion. So I can say this is 2 Newton. The force applied is F applied is 6 Newton. So now the acceleration of 2 kg will be written as net force is 6 minus 2 divided by 2, so 4 by 2, that is 2 meter per second square. Now what happens? The upper block is accelerated more and the lower block is having less acceleration, so there will be relative acceleration, and the relative acceleration can be written as 2 minus 0.5, that is 1.5 meter per second square will be relative acceleration. Now let us take the fifth example with some numerical value. Now let us take two blocks are there, one plank is there, right? And this plank is of mass, let us take 4 kg. This is placed on the ground, and let us take the mu s is 0 between 4 kg, and the block is, this is 2 kg, and the force applied is here 6 Newton, right? And the value of mu s between 2 kg and 4 kg is 0.1. Now in this case we have already seen it will have the lower block will have fixed acceleration. The acceleration of the 4 kg will be nothing but 0.5 meter per second square, and the upper block will have acceleration A2 kg will have 2 meter per second square. So the relative acceleration will be equal to 1.5 meter per second square. Now if this length of the plank is, let us take 15 meter, then what will happen? This is moving slower, this is moving faster. So after some time this will fall in rightward direction. So what is that time of fall? After which time the upper block will fall ahead and will fall in rightward direction? I can write that is half AR T square 2 L by AR, and this is converted as 2 times length is 15 meter and AR is 1.5, 15 into 10. So I can write 20 root 20, 4 into 2 root 5 meter to 4 root 5 second. A second is the time after which this block will fall on rightward direction. Is it clear? Now in the 4-5 situation, this is the fifth example we have taken. This one. Now one more example will be there when this is connected to a pulley and then there is a block attached. What should be value of this force? Let us see that situation also. What will happen to the common acceleration? Now the next situation we are going to see is Now this force F is not applied here. Now in this example, question 6, I can say now there is a pulley here, and now this is the situation, and there is another block M0 here, M0, right? Now what is the same situation? Coefficient of friction between upper block, lower block is mu s, and this is smooth. Now what is question number 6? Let us say question 6. What should be M0? M0 is how much to keep M and M move together, or the upper block does not slide over the, or I can also say M does not slide on M. Right, so this is the situation. How can we find out?